What we have today is finding unknown angles. Within trigonometry, as long as we have either an angle on a side, we can find the other two sides. Or if we have two sides, we can find the angle. So how are we going to find these unknown angles? Well, everything goes back to the acronym for trigonometry, SOHCAHTOA. So we have these three ratios. So sine is going to be opposite over the hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So using these ratios, we can find our unknowns. So let's say we have this guy Dan walking through a forest, coming upon a tree. He figures he's about 40 meters away from this tree, and he has an angle of elevation of 35 degrees. If he's 2 meters tall, how tall is this tree? Well, first thing we know is we are 40 meters away from the tree, and the fact that Dan is 2 meters tall. What we have to find is the unknown, this side being x. So using our side ratios, we can figure which of these three trig functions we can use. So we have the side opposite and the side adjacent. So opposite and adjacent means we're going to be dealing with tangent. So tangent of 35 degrees is equal to our unknown x over our adjacent side 40. To figure out x, we just multiply both sides by 40. That will cancel out on the side with x, leaving us with just x equals, and then we'll use the calculator to figure it out. So again, anytime we're using the calculator, we want to make sure that we're in the appropriate mode. So if I click mode, I see I'm in radian. I just scroll down and over and select degree. And then I go back. So we have 40 times the tangent of 35. So we get 28. So we know from the top of the tree to where Dan's eye line is 28 meters. Now we have to factor in the fact that not only is this part 28 meters, but the bottom part is as tall as Dan is. So from here to the ground is 2 meters. So the whole way would be 28 and 2 being 30 meters. Now let's say Dan turns around and he sees another tree, and he's betting that it's at least 50 meters tall. So the whole way from top to bottom is going to be 50 meters. He's wondering what the angle of elevation from his eye line is. So here is our unknown x. So over on this side, we're still dealing with him being 2 meters tall. We have an unknown x. Fortunately, we are also 40 meters away from the tree. So what is this angle of elevation going to be? Well, first of all, we have this right triangle, so we have to take out this bottom part. Now again, Dan is 2 meters tall, so this means from the top of the tree to the bottom of his eye line is going to be 48 meters. So that's the number that we're going to be using when we have to figure it out. So we have the side across from x, opposite, and 40 meters is the adjacent. So opposite and adjacent means we're still dealing with tangent. Only in this case, we don't have a number, we have a variable. So we have tangent of x is equal to opposite 48 over 40. Now, how do we get what the value of x is? Well, there's something called arcsine, arccos, and arctan. Basically, it's the inverse function. It does not mean 1 over sine, 1 over cos, or 1 over tangent. It just means going backwards. So if I want to figure out what x is, I'm really going to be taking the arctan. And what you'll see is I give it an exponent of -1. Of 48 over 40. So I know the ratio of the tangent of our angle is 48 over 40. So to figure out what the angle is, I take the arctan or inverse tangent of 48 over 40. And if you take a look at the calculator, notice in yellow above each of the trig functions, we have sine -1, cosine of the -1, tangent to the -1. We're going to use those to figure out the angle measurement. So again, our calculator's in degree mode. So second tan, notice we now have tangent to the -1 of 48 divided by 40. We hit enter and it gives us 50.1944. So we just round, we'll do nearest tenth, 50.2. So we have x is 50.2 degrees. So that is using our trig functions to figure out angles of measurements. And again, anytime we are given a right triangle, any measure, whether it's angle A or angle C, in this case here, we can take arcsine, arccos, or arctan to figure out the appropriate angles. So sine -1, cosine of the -1, tangent to -1. Those are the arc functions for trig. And we can do that for any right triangle. So as long as I have two sides, I can figure out the missing angle that we are tasked to find. So this one, we got 4 different triangles. First one, we have angle A with sides 13 and 20. So 20 being across from the right angle, there's our hypotenuse. And 13 being next to our angle, there's our adjacent. So adjacent and hypotenuse means we are dealing with cosine. So cosine of angle A is adjacent 13 over 20. We'll now take the arc cos. So A is going to equal cosine of the -1 of 13 over 20. And again, using the calculator, second cos, 13 over 20, gives us 49.45, so we round up to 49.5. So A is 49.5 degrees. B, we're given sides 40 and 42, and here's angle B with the right angle. Again, any side across on the right angle, there's our hypotenuse. 40 happens to be across from angle B, so opposite. So opposite and hypotenuse means we are going to be dealing with sine. So sine of B is going to be opposite, 40 over the hypotenuse, 42. So to figure out what B is, I have to take the arc sine, which is just sine to the -1 of 40 over 42. So we'll use the graphing calculator here to get 72.25, 72.2, rather 72.3 degrees. For C, we have sides 14 and 29 with angle C. So I take a look at the relationship. 14 is across from C, so there's our opposite. And the one next to C here is the adjacent side. So opposite and adjacent, dealing with tangent of angle C is opposite over adjacent, 14 over 29. So we take the arctan of our ratio, and we get 25.8 degrees. Now these are making sense because if I take 49.5, it almost looks like a 45 degree angle. It's slightly bigger, but it works. 72.3 means we got a bigger angle. 25.8 means smaller angle. So these numbers are making sense. And finally, for D, we're given angle D. with sides 68, 85, and 51. Because we know all three, it's basically our pick to use whichever ratio we want. So we could use sine, cosine, or tangent for any one of these. So side across from 85 is from the 90-degree angle. There's our hypotenuse. Side across from angle D is opposite, which means last one's going to be our adjacent side. So again, we have our pick of all three. Might as well use sine. Sine is good as any. So sine of angle D is opposite over hypotenuse, 68 over 85. So we take the arc sine of our ratio in order to figure out what angle D is equal to. So second sine of 68 over 85 means we get 53.13. Now, if we had picked cosine, cosine would be adjacent over hypotenuse, so it'd be 51 over 85, taking the arc cos to get angle D. So this will just show you why we could have used any one of them. So 51 over 85. Notice we get the same thing, 53.13. And if I did the arc tan, opposite over adjacent, 68 over 51, I get the same thing. So this is why we could have picked any one of the three. We'd have gotten the same thing from either one. So 51.13 degrees. So that is using arc cos, arc sine, or arc tan to figure out unknown angles within a right triangle, as long as I know two out of the three sides.